my name is Lindsay and this is Yang. And in this opportunity, we would like to present our multimedia innovation project, which calls Sleep Companion for Elderly. So this idea was formed because of an important problem that often overlooked, that many elderly keep their daily emotion for themselves, including anger, sadness, anxiety, and stress. And these unrealized emotions are critical because they can lead into various negative things such as poor sleep quality, negative mood, and the next day, long-term health issues such as hypertension and depression, and potential risk of cognitive decline, or we call it dementia. So this is the problem that we're facing, and we often don't share their feelings with family or caregivers, so their emotional state is unknown. So that is why we designed this project with the concept of encouraging elderly to express their daily experiences and feelings through voice. The system then detects the emotional state of the day and prepares the personalized multimedia therapy based on the detection emotion. So if the system detects the emotion of the day was angry, so the multimedia therapy will be a flow with animations, soft with tones, and etc. Now, with this program, we hope that elderly's mood can become calmer and more stable, and helping them prepare for a better sleep and more positive at the next day. And in addition, our system provides a weekly report showing that how many times in the past 7 days elderly felt sad, happy, sad, angry, or anxious. And this report can help family members or caregivers better understand the elderly emotion and provide more appropriate support and care. And then these are 4 things why this program is useful. The first one, emotional well-being. This program can help elderly release their emotions safely and can reduce their stress and tension. The second one, sleep improvement. By release their emotion, it can calming their mood and also improves the sleep quality and overall health. The third one is family awareness. We have the weekly reports that allow caregivers or family members to understand emotional patterns and provide timely support. And the last one, preventive health, can reduce risk of stress-related illness and cognitive decline or dementia.
Okay, so the mechanism of our project is first we input the voice using the recorder, and then it will change the voice into the text, and then we use the emotion detection using NLP model, and then based on the processed language, we use the emotion-based language, and then we give the multimedia therapy output. Okay, so the existing model, we use the Whisper AI to change the speech to text, and then use the NLP model, transformer, is to use to decide the emotion. Then this is the system library that we use. We use NLP to process the audio, sound device to record, Skippy to convert the file into WAV file, WAV, and then Torch to learning the emotion, Transformer to analyze the emotion, iGame to user interface, and OpenAI Whisper to speech to text, Python VLC to play videos for the therapy, and then ITTS X3 is to read the emotional support. Okay. And then our self-developed component is the therapy type. We decide which emotion is suitable for which therapy, and then the audio selection also the same, also with the visual style, and then the emotion decision we use to record For example, I said about two sentences, and then we divide it by per clause to decide whether it is sad, angry, anxious, or happy. Then also the user interface. We display the recording state, result display, the therapy, and the weekly emotional summary. Okay.
So the novelty of our project is that we do not simply detect emotion and then just stop there. Instead, the system responds with appropriate multimedia therapy after the emotion detection. And so our focus is on emotional release, not just for emotional analysis. We also implement an end-to-end system integration that combining speech processing, AI analysis, multimedia output, and fully functional interactive pipeline, and also modular and accessible design. And the most importantly, our major contribution is human-centered emotional design. We didn't design this project for performance speed or visual excitement. Instead, we focus on emotional safety, low stimulation, and the specific needs of elderly. And this is for the work division. Let's move on to the project demonstration.
So here let me show you the weekly record. Here total is 14 sessions. We have set 6 times, happy, angry, and anxious. Okay, and then back. Okay, then the main function is to record, and the recording.
Today I went for a short walk and talked with my old friend and feel quite happy and relaxed.
Okay, so the detection and the program will detect the input, and then it will show what does the emotion based on the text. Okay, and in the result we also show what is the input, and then the suitable therapy for it. And then to play the therapy, you just click this.
Enjoy this peaceful moment.
Then we play the video like this. Okay, because this is the emotion happy, and then the second one is to check whether it is have the more than one emotion. For example, like happy and sad. So it was a mixed emotion.
I was happy to hear from my family today. At the same time, I felt sad because I missed them and they are far away.
Okay, so from the input we detect the emotion is happy and sad, and it was happy from this, happy to hear for family, and then it feels sad because miss them and they are far away. So the emotion detected as happy and sad, and so the result is because let's see the log and the log session log. So from this is we can see it was divided into two clauses. This birthday as happy, and then this as sad. So because the score of happy happy was higher. So the
Hands up. Conclusion. Hands up.
Okay, so as he mentioned before that the score stat was higher. So if we play the term,
It's okay to feel this way. You're
so
not
if we
alone.
play the stat term. Okay, so okay, that is all for our presentation. Hope this can help the elderly to feel better. Thank you.
下一组。
那刚刚那个评分表各位都有填哦，每一组都要评哦。那个是，对，
啊，对对对，
最后一份。
那个报告的时候再抬头停久一点好了，因为可能大家选一下那个表单。OK。不要照那个先，那10号，那个不要迟到。
喂。
Good afternoon, everyone. Our project is called Virtual Partner for Widowed Elderly. We are Lin Xuanyu, Lin Yuwei, and Huang Bohan. In this presentation, we will introduce an AI system designed to provide emotional companionship for elderly people. Our motivation comes from studies showing that elderly people who lose their partners often experience serious loneliness. After a loss, social interaction is reduced and they feel unhappy. And in the long term, this loneliness can increase the risk of dementia. This emotional problem is common but not easy to solve through traditional methods. Our solution is an AI-based virtual companion system. We both elderly partners are still alive. The AI device collects and records their daily conversation and interaction patterns. This data allows the AI to learn their language style and personality traits over time. When one partner passes away, the AI is displayed on a screen as a virtual companion created from the learned data. This virtual partner can continue to have conversation with the surviving person, providing emotional support and a sense of presence. However, there are also limitations. First, we don't have enough data to fully recreate a person. Secondly, our system cannot achieve voice cloning or realistic text-to-speech. Because of these challenges, we needed to clearly limit what our system can do. So we defined a clear scope for our project. We only use one-to-one chat history stored in plain text files. Users interact through keyboard typing or speech to text. The AI responses are presented only in text form, and our focus is on personality imitation, not facial biography reconstruction. Okay. These systems can be applied in several areas, including emotional support, digital memorial systems, human AI interaction research, and personalized conversation agents.
We use the Gemini API for personality extraction and response generation. Firebase Firestore is used to store memory profile in a JSON-based format. In addition, the Web Speech API enables the real-time speech-to-text input in both Mandarin and English. We use Express.js as the HTTP server framework. Matter is used to handle file upload, such as chat history text files. This tool allows us to build a stable and scalable web-based system. Self-development components include custom prompts designed for personality extraction, chat history preprocessing, and memory profile schema design. We also implement persistent chat room management and user-friendly error handling. The novelty of our system lies in its emotional realism. Instead of behaving like a generative chatbot, the AI reconstructs a persona based on authentic language patterns. This makes interaction feel more personal and emotionally meaningful. This slide introduces our system integration. Our system seamlessly combines AI models and the database, voice input, and the web interface. All components work together in real time to provide a smooth user experience. The AI personality can be reused without re-uploading the same data. And this slide focuses on the overall framework design. The system supports multiple disease profiles for a single user. Its modular architecture allows future model replacement or feature expansion. This design improves scalability and long-term maintainability. And this is our division of work among our team members. Okay, let's start our demo. And first, enter our project folder. And use Node to get our link. Okay, now we're at the uploading part. So you can type the name of the person you want AI to imitate, and the name of the chat room you want to store in the database. And like this. And then upload the TXT that contains your conversations. And now we can start analyzing. And this takes maybe 1 minute, so let's check out the things. The TXT we need looks like this. You can upload this from Line directly. And here's our Firebase, the database. And it stores the information that Gemini extracted from the TXT, like the description of the person and the sentences he commonly used. Okay, and after it finishes the analyzation, it will jump to this chat room automatically. So we can check our Firebase again, and we can see the new entry here, and also the new content. So we can try to type something and see how he replies. And the audio icon is just for decoration now because we haven't finished the voice call. Okay, and also we can use voice typing. 当时上都找好了没？ And additionally, you don't need to worry about the chat history disappearing because every time a message is sent, it will be stored back to the Firebase as well, like this. So every time you refresh the page and click it again, you can still see the messages are here. So you can continue your chat. Okay, that's all for our demo. Thanks for listening.
那就是等一下上台的时候，你们自我介绍的时候，要讲一下，稍微讲一下说你们自己是谁这样，就是要分得出你们名字对到哪一个人这样。
Hello everyone, I'm Lee and he's Dante, and our topic is about diagnosis. Okay, so our project is Diagnosis Result AI Generator. And first, why we going to make this app is because We think an elder patient may forget specific medical instructions such as dosage, timing, and precautions. And sometimes medical terminology is often too complex and need to be translated into straightforward everyday language. So our solution is to make an app that combines high precision AI speech recognition and LLM analysis. It transforms tedious diagnostic process into simple summary for seniors.
And here are our project workflow. So the first part is record and upload. We use audio recorder to capture the dialogue and send it to our backend server. The second is analysis and processing. The backend handle audio segmentations. Use Google Speech to Text for transcription, and Gemini generates a structured JSON summary. The third part is storage and feedback. Once frontend receives the result, it is saved to NSYNC storage and present the result on screen. And here are our current modules and models we use. First is Google Cloud Speech to Text. We choose it because it supports speaker labeling, so we can identify who is talking. Then Gemini 3 tailor transcript and structure it into 5 key modules: diagnosis, restrictions, red flags, diet, and follow-up. On the front-end system, we use Expo AV to control audio recording and playback functionality. Expo Speech for voice narration. Expo File System to manage audio file before they are uploaded. NSYNC storage is about local data persistent for sorting consolidation history. And here are our self-developed modules. The first is Recording Logic Manager. This encapsulates the recording logic and manages stage transition like recording, pause, uploading with real-time feedback. The second is our visual summary. So it takes the context JSON from the LLM and transport it into simple carousel interface. And the third part is, and this implements the logic for creating, reading, and deleting about medical record in the local database. And last, we design a specialized system prompt to instruct the LLM on our requirements and output a specific JSON output format. And here our framework. We utilize Reactive and Expo. It is responsible for several tasks such as voice recording, display the result, history management, and UI rendering. On the back end, it serves as a computational engine of our system, focusing on AV data processing and API integration. And we use FFmpeg for audio pre-processing. Make sure it is stable, like format conversion or noise reduction.
And this is our major contribution of project. So we use technology to solve the problem where seniors struggle to fully understand medical instruction due to the memory decline or the inability to quickly grasp what the doctor is saying. And we also develop a medical speech to summary pipeline. It integrates speaker dialization and LLM to transform unstructured dialogue into structured summary instantly. So when we develop our app, we encounter some problems. The one is the API key security awareness. So API key are highly confidential credentials, and strict management protocols must be established during development and usage to prevent leakage. And the other problem is the STT speaker diarization. So we first use Chinese to recognize. So, and it fails because we found that the poor accuracy in speaker dialization. So we switch the dialogue to English to solve the identification issue. And we found that current mainstream models are much more optimized for English than for Chinese. This is our teamwork. And Li is for backend and AI engineering. And for Zhang Tingwei is for front end and app development. So
hello everyone. Today I'm excited to present our final project, a medical transcription and analysis app designed specially for elder care. This is a mobile application using React Native and Expo that capture audio, processes it through a server, and automatically generates structured medical summaries. Let me show you how it works. Let's start with the primary feature. Here, we have the record tab. The interface is designed to be clean and intuitive for patient. I will now demonstrate a live recording. Imagine a scenario to simulate a diagnosis of suspected hypertension.
Morning, this is Smith. How are you feeling today?
Well, doctor, not very good. I've been feeling a bit dizzy for the last 2 days.
Let's check your blood pressure first. It's 158/95. That's a bit high.
I went to a wedding party, so I might have eaten some salty food.
That explains it. Also, it looks like acute gastritis.
Oh dear, what should I do?
Try some medicine, but remember, absolutely do not eat grapefruit.
Okay, no grapefruit. Can I eat porridge?
Yes, keep your diet bland. Avoid spicy foods.
Alright, what if I feel chest pain?
If you have severe chest pain, call an ambulance immediately.
Okay, next Wednesday morning for follow-up. Thank you, doctor.
Once the consultation is finished, I simply stop the recording. The audio is now saved locally and ready for processing. When I submit the audio, it is sent to our backend server. We are using Gemini API to transcribe the speech and extract key medical information. As you can see, the app has successfully processed the conversation. Instead of listening to the whole audio file again, the patient sees a structured summary. It highlights the subjective information that the patient forgot his medicine and the objective data from the checkup. This automatic summarization saves valuable time for the patient to understand their actual condition. And for every part, you can press the read button to read the information loud and clear. And one of the key features we implemented in this update is the history storage. Medical care is continuous, so keeping track of past records is essential. In the History tab, we store all previous sessions locally. I can easily browse through past consultations. For example, this analysis is for COVID-19. This analysis is called Tong. So as you can see, patient can immediately retrieve the full analysis and summary without worrying about the past analysis disappear. To summarize, our app combines an intuitive front-end built with React Native and a powerful back-end or LLM processing. It bridges the gap between patient interaction and digital documentation. Thank you for watching our demo, and we hope this tool can make a real difference in the workflow of elderly care facilities.
Okay, so this is the end of our presentation. Thank you.
Hello everyone, we are here to present our project. And I'm Ye Jiayu, she's Chou Guanzhen, and she's Liao Zijing. This is a Python-based application designed to combine visual recognition and speech synthesis to help the elderly. Let's talk about the motivation. We identify two challenges in elderly medication. First is vision decline. Elderly people often have presbyopia, making small text on medicine bags hard to read. Second is medication safety. Misreading dosage or time causes serious risk. Our solution is transform text into voice and large icons through the simple action of taking a photo. Here is the overview of our system architecture. Image input. User takes a photo of medicine bag, then system loads the image. Core processing. We use OpenCV for image preprocessing, TensorX OCR for text recognition, and regex for information extraction. Output feedback. The system provides feedback via HTTPS voice reading and generates visual icons. Here is the development scope. Current modules. We use OpenCV for image processing, such as denoising, thresholding, and cropping. For optical character recognition, we use TensorX with the traditional Chinese model. For audio, we use HTTS, a Microsoft online speech engine that provides natural accent. For interface, we use TK-Inter to our GUI framework. Self-developed. We developed a regex parsing algorithm to filter noise and extract specific medication usage. We also built the icon mapping logic to visualize the dosage time. And we designed a senior-centric UI flow for better usability. Now let's talk about the core function 1, image recognition. Instead of scanning the whole image, we use ROI localization, region of interest. We identify the template coordinate for specific hospital formats, such as TVGH. By using relative coordinates, we can crop 3 key areas: the patient's name, the medicine name, and the usage instructions. To improve OCR accuracy, we perform pre-processing on the cropped images. First, we convert the image to grayscale to simplify color information. Next, we apply a bilateral filter to remove noise while preserving edges of the text. Finally, we use auto thresholding to separate the text from the background. For the actual text recognition, we configure TextRX with specific parameters. We load both the traditional Chinese and English language text, and we set the page segmentation mode to 6. This setting is optimized for recognizing a single block of text, which is perfect for our cropped images. Now let's talk about the core function 2, data parsing. This is our parsing logic. For name parsing, we find 2 to 4 Chinese characters following name. For medicine filter, we remove headers like Chen name or scientific name and prioritize Chinese characters over English noise. For usage extraction, we detect keywords like morning, noon, or night and extract the dosage numbers. Why we need parsing? Because raw text output from OCR often contains noise or errors. To fix this problem, we use regular expression to extract valid information. Now let's talk about the core function 3, speech synthesis. First is text optimization. We convert rigid medical text to spoken language. For example, 3 times /day becomes 3 times a day. Second is HTTS engine. We use the Xiaozhen neural voice model, which sounds much more human than standard robotic system voices. Third is senior-friendly settings. We set the speech rate to -25%. This deliberately slows down the speech to ensure seniors can hear every instruction clearly. Now let's talk about the core function for visualization. The text is converted into easy-to-understand symbols. One triggers a sun icon, one triggers a cloud icon, and I triggers a moon icon. There are also special instructions for detecting actual meal and adding a place icon. Here is our user interface designed with TK-Intro. We follow the principle of large text and high contrast. The operation consists of only 3 color-coded buttons. Blue buttons to select the photo, green button to start the analysis, and orange button to replay the audio. Here is our major contributions. First is system integration. We integrated offline OCR, address parsing, and high-quality neural DTS into a unified Python application. Second is novelty and accessibility. Our system is specifically designed for seniors. Therefore, we use large fonts, a high-contrast interface, and a customized -25% speech rate for better comprehension. Here is our teamwork. Liao Zijing focuses on UI design, icon visualization logic, system integration and testing, and I focus on OCR integration and matrix parsing algorithm. Chou Guanzhen focuses on speech synthesis, system integration and testing. Finally, let's demo.
When we open our smart medicine helper, we have to click the button to choose the picture of your medicine bag. And once you choose the picture, you can click the green button to start analyze.
杜健康您好，这包药是药名滇通长效膜衣定2200毫克，请注意用法，口服每日3餐后每次1粒。
And you can see the full picture, so you will know you should take the medicine after eating. And if you want to listen it again, you can click the button to.
杜健康您好，这包药是药名 滇通常效膜一定2200毫克。请注意用法，口服每日3餐后每次1粒。
And that's all for our presentation. Thank you.
Hello everyone, we are Team Studies AR. Our team members are Zhang Yaojun and Yaojun. Now my name is Zhang Yaojun. Our final project is titled Studies AR, Your Home at Home Safety Coach. We are presenting an innovative multimedia application specifically designed for elderly fall prevention. This project is deeply rooted in the USR goal of co-creating a happy life for the elderly. We started with a simple question: what is the foundation of happiness for senior citizens? The answer is health, and for the elderly, the biggest threat to health is falling. Therefore, we believe that safety is the foundation of happiness. Let's talk about the problem we observe. As the population ages, many seniors try to stay healthy by exercising at home. They usually follow videos on TV or YouTube. However, we identified a critical flaw in this approach. It is passive. Think about it. A YouTube video cannot see you. It cannot tell you if your back is too bent or if your knees are weak. This leads to our main problem: unsafe exercise. For a young person, a wrong posture is just a mistake. But for an elderly person, a wrong move can lead to a serious fall or fracture. Existing solutions fail to protect them in real time. Therefore, our project scope is very specific. We target indoor safety monitoring for seniors over 65, focusing on low-intensity balance training. To solve this, we designed a closed-loop feedback system. Here is our architecture. First is the input. We use a standard smartphone camera to capture the RGB video stream. We choose this because every family has a phone. No expensive equipment is needed. Second is the processing unit. This is the brain. It consists of 3 parts: a vision module to find the human body, an AR module to understand the room environment. Most importantly, our logic module that analyzes the movement for safety. Third is the output. The system provides audio feedback and visual overlays to guide the user instantly. If they are doing well, we encourage them. If they are in danger, we warn them. Now, let's dive into the implementation details. We carefully integrated robust existing modules with our own self-developed code. Current modules used: we selected Google Media Pipe for post estimation. We choose it because it is lightweight and provides high fidelity tracking of 33 key points on mobile devices without lag. We also use AR foundation for lag detection. Self-developed contribution. This is the core value of our team. Our MediaPipe giving us the raw points, the XY coordinates. It doesn't understand safety. We develop the safety logic algorithm. We wrote a Python code to calculate vector angles, specifically the alignment between the hip, knee, and ankle. We also developed the interactive feedback system. For example, if the calculate angle drops below 140 degrees during a standing exercise, our code triggers a red alert. In our demo today, we visualize this logic using a skeleton overlay to clearly demonstrate how the system checks the joints and calculates angles in real time. So, what makes steady-state AR unique? Our major novelty is the shift from fitness tracking to the safety monitoring. Most apps care about how fast you run. We care about how safe you are. Furthermore, we propose the ghost coach concept. Many seniors struggle to understand 2D videos. Our solution uses AR to project a 3D virtual coach right into their living room. It's like having a personal trainer standing next to you. This immersive experience is the first of its kind, designed specifically for the elderly. And finally, here is our team contribution. Thank you.
Okay.
As mentioned in our presentation, we want to prove that our safety logic algorithm works in the real world. We have ported the core logic from our mobile app to this laptop for live demonstration. What you see here is a real-time video feed from the system. First, please look at the green skeleton lines overlaid on the body. This represents our visual module powered by MediaPipe. As you can see, the system steadily tracks the key joints, shoulders, hip, and knees. In real time, this provides the raw data for our system. And now please focus on the right number, displayed near the knee. This number is not from the pre-trained model. It is calculated by our self-developed algorithm. We wrote the code to instantly calculate the vector angle between the hip, knee, and ankle. Currently, I am standing straight, and the angle is around 160 to 170 to 180 degrees, which is considered safe. And now let's simulate a dangerous situation. Imagine an elderly person performing a squat, but going too low due to weak muscles. As the angle drops below our safety threshold, 140 degrees, and the system detects the danger immediately. The skeleton turns red, and a warning message appears. This is our real-time safety feedback. It alerts the user before they actually fall or get injured. And once the user returns to the correct posture, the system resets to green. This demo proves that our code doesn't just record video, it understands safety. And Thank you.
Hi everyone, we are Team Generational Gap Mediator. I'm waiting. This is Yang Boxun, and this is Chopin. So we do a cross-generational communication through technology. So here is the problem we observe and our motivation. So elderly cannot understand memes, then only share fixed style good morning images, leading to feelings of exclusions. And young is difficult to reply a fear of sharing life because elders won't understand. And these two problems lead to the result. Family members feel disconnected despite being in the same chat. And here is our solution, a digital bridge communication assistant. And the first one is AI meme translator. So the bot explains the meaning of memes in senior-friendly language. And the second is greeting card 2.0 generator. And it creates elegant greeting cards using voice or text. And so here's our project framework. So the builders can use our front end and input text, images, or voices. And our Python router will process the data and send it to AI core, and the AI core will generate the result due to the processed data and send it back to front end and show results. And let's talk about the front end React-based website. And here's our front end system. So the base is a create React app, and there's 3 contexts to manage the statement and 3 pages. The home page is to introduce how to use the whole system, and the meme translator page and card generator page is our function. And there are 3 tools: FR, FUBAR, and voice recorder.
Let me talk about our backend system. Our backend system is like a bridge to receive data from the website and send data to the AI service, and we receive back the data from AI service and then send to the website. Here's is the backend system module using. The main module is Python Flask to create the APIs to transfer data. In first APIs, we use 3 types of API to receive 3 types of types. Then the graph receive text and audio. First, if we see audio in the backend, we will use speech recognition to transcription to the text, and then if API receive text and the image, we will send to the AI service.
Now let's move on AI core logic. And on the left is AI meme translator. It's powered by GPT-4 Mini, and we add a constants and dictionary to query dictionary first, preventing AI hallucination. And we we use a neighborly personnel and it follow a structured response flow to ensure the communication is elder-friendly and warm. And on the right is greeting card generator is powered by GPT image 1E. And to preventing image repetition, and we automatically randomize the media and perspective and subject. And to optimize the text integration, we guide the AI to attach text to a physical object like woodboard paper.
And here is our key contributions and innovations. So first is on relative. Characterized AI expansion, so it's like neighbor persona, and system integration. Retrieval first strategy with custom slang dictionary, and then technically career-oriented text generation, solving a mere flaw in current diffusion models for text placement. And it's our teamwork and growth. So I'm doing the front-end development and UX, and I'm pushing to the back-end system and server logic, and totally to the AI model development and data processing. So it's our solution, bridge cards, not just words. And let's go to the demo. And here's our homepage. So homepage will introduce the whole app, and it will introduce why we do this app and the problems in Taiwan and our solutions and how to use the app. So it's so let's improve the meaning and sound. So it will translate what is this mean, like this. So it will say what is and mean is now you know what I'm saying, and it will care about the elders. So for the images. So the images is 回答 okay, and you will say what is the meaning. So it says 回答我 is want you reply question. Is how to say. So let's try this. And so the voice, the front will process it to grab and send it to the backend. So, and the backend will process it and throw it to the AI, and it will translate. So I'm saying is, you know how I'm saying. And let's go to the greeting cards generation. So you can choose the card style, and you can input your words. And here is some examples. So I will use the example again. So it will create the greeting cards. Like this. So we input 早安，今天要开始。Here is 早安，今天要开始。 and try our voice recording. The AI generating will be a little bit small. And so he says 早安你好 and the AI generates 早安你好 like this. And we also do two language websites, so we can translate to English. And here's how the English website looks like. So, and here is dark mode and light mode change. So we can use the dark mode. And also here is a big font mode. So when elderly his sight is not that good, he could use a large font mode. So he could see the words clearly. And here is our presentation. Thank you very much.
您是做 break 吗？我看你下过程没有？下过程没有做。
说 break
啊，对啊。
哦，我用过自己。
所以你是收集很多密，然后丢在你
对。哦，
了解。我是。
is using AR for converting elder's digital image from 3D to 2D. This is 2,000番南线语. So our motivation is to turn a photo into a 3D avatar and place the elder's loved ones into a real space with AR. Also, capture simple 2D group photos for the seniors. So, related work. We were inspired by VTubers using 2D or 3D avatars. They typically use Live 2D and Blender. They use face and body tracking with microphone. Also, uses real-time streaming to the viewers. And our direction is a simplified version. We have no motion capture, no streaming or broadcasting purposes. And we focus on simple interactions with a memorable photo. So our problems and scope applications for this project is that seniors often feel distant from family that lives far away. And using 3D VTuber systems, we have a high learning curve with lots of hardware, so it's not quite achievable. So our solution, photos are simple, but lacks a sense of presence. So we use a mobile phone only, and uses a single person's photo into a simple 3D avatar with a short AR interaction and a commemorative group shot. So our applications will be used in elder care centers, home care, or remote families, and memorable keepsakes and special occasions. So our system overview is we first upload the photo and generates an AI avatar. We then uses a AR environment sensing placement, and we now project 3D to 2D onto a full screen. And now we capture and save the group photo. And so for our diagram, we have blocks for AR modeling, AR foundation, Unity app, and camera capture. So we have the existing modules. Here's our self-developed parts. So existing models, we have Ready Player Me or something similar for AI avatar generated. And we use a standard .glb with skeleton for our 3D modeling format. We use the Unity AR Foundation, AR Core, /AR Kit for our AR environment sensing. And we use Unity 3D for rendering engine. So we have interaction UI flow. We developed interaction UI flow for seniors with a simple click for a photo. We also have AI avatar placement and animation presets for giving scenarios. We have a projection logic for best pose for group photo, and workflow integration from a cloud model to a mobile AR into a 2D export. So in detailed framework, we have 3 core modules with automatic AR modeling. So we upload a 2D portrait, and the cloud AI triggers a 3D avatar. And for AR space projection animation, we use plane detection with SLAM. We have 3D avatar anchored in the real world. And we also have predefined gestures and idle animations. And lastly, we have a 2D photo capture and storage. From 3D scene to a 2D screen with a projection matrix. So we have a one-tap capture, save to gallery, or printed. So these are our major contributions in novelty. For novelty, we turn a temporary presence into a permanent 2D keepsake. We focus on elder usability with no gear, no tracking, and no streaming. For our system integration, we connect AI avatar generated to AR spatial computing to a mobile photo capture into a single pipeline. So we reduce the full VTuber style workflow to a photo and tap. So our impact or application value, we should strengthen emotional connection and presence of business family members, and practical for care centers and home visits. So for our conclusion and possible future work, AI plus AR turns photos into living companions with zero barrier interaction for seniors. So for the future, we can implement richer emotions and voices, multi-person AR scenes, and privacy and consent management. And this is a displacement of our teamwork. And now we can move into demo.
Now let's move on to our live demo. It is designed to be easy for the elderly people, so we use it on the mobile phone. As I use the app, you can see our preset 3D model appear on the screen if you look closely enough. And we can tap the photograph button to take a photo. And the photo will be automatically sent to our phone storage right here, like this. And although this demo is still a work in progress, there are some issues, such as the model sometimes not rotating with the camera and the scale not matching reality perfectly. The model can be small or really big. And we plan to refine these features in the future. And that's our presentation. Thank you for your listening.
有。Our project name is Easy Hawk, a home rehab support system for elderly. This project focuses on making home exercise and rehabilitation easier for elderly users. The main problem is that when people practice at home, they usually don't know if they are doing the movement correctly. So they feel unsure, lose motivation, and stop practicing. Going to a clinic can help, but it also takes time, transportation, and money. So it's not always realistic. That's why we want a solution that works at home, gives guidance, and helps users keep going. For a scope, we focused on a laptop-based web prototype with 2 modes, sit and stand. We used a webcam with media pipe post to check base landmarks and provide real-time feedback during practice. Together with short tutorial clips and a simple session flow. What we did not cover in this stage is medical-grade diagnosis and personalized rehab plans. We mainly aim for guides, practice, and safety reminders.
And for this slide, it's basically what we use and what we build ourselves. First, so for what we use media pipe with the laptop webcam to detect the user's body landmarks and track movement in real time. We also built the system as a web-based interface, so users can use it directly in the browser. And additionally, to support rhythm-based pacing, we use Suno AI to generate background music. So the training builds more structure and helps us users keep a steady tempo during exercise. Then for what we build, we implement the core interaction logic, including posture tracking, repetition counting, and real-time feedback on the screen. So users can adjust immediately while they are moving. And besides the detection part, we also create our tutorial content. We record the guidance video ourselves. And for our contribution, it's mainly 3 things. First, we design 2 modes, stand and sit. So users with different mobility levels can choose what feels safer. And second, we made the tutorial video short and step by step, so it's easier to follow and more likely to keep practicing. Third, we added the real-time messages, not only to remind users when their posture needs adjustment, but also to give encouragement, so the experience feels less boring and more motivating. And this is our demo time.
Okay, first we open Easy Hawk in the browser, and after entering the home page, this on the front of it is our logo title, and here has 2 buttons. It's about mode. There's a 2 modes, stand mode and sit mode. Depending on the user's mobility level, then the intro guide video starts. We choose stand mode.
你敢有身躯顿顿袂溜了？我会当带你一步一步来做一寡简单的复健运动。咱对荧幕上的人做伙叮当吧。
And we'll see the webcam view on screen. And an important point is the workflow will only start when the system detects the user standing inside the camera frame. So once the user steps into view and stays in position, the system is ready to begin. The users follow the tutorial video on the left, step by step during the exercise. Each step provides real-time feedback on the screen. For example, it tells the user whether the posture is correct. And before the next movement begins, the system also gives a preview prompt, so the user knows what's coming next and has time to prepare. And then the user performs the movement well. The system gives positive encouragement, like a compliment, to keep the user motivated. Okay, that's our demo. It's our teamwork ratios. And thank you. Thank you so much for listening.
要说点什么？你要看什么？还是非常说？
Hello everyone. Today our topic is Happy Life Restarting. I am Li Chongyi and my roommate Wu Songyu and Liu Deyi. So we want to explore a companion-based digital system to support elderly daily life. We aim to help elderly to manage daily routines, such as taking medicine and going out. We use simple UI to provide easy interactions, combined with mini games, reminder system, and daily tasks. And our goal is to show care using technology. As society is aging, many elderly people face daily challenges, such as forgetting important tasks. An existing health system often focus on monitoring and data, but lack emotional support. And elderly didn't receive enough positive feedback when finishing tasks, but over-reminding will cause stress. Also, lack of socialization makes elderly feel pressured or resistant to technology. And our motivation is to provide emotional support through technology, combining daily reminders with interactive UI for motivation, mini games to bring enjoyment and relieve stress, and mini tasks to maintain a sense of purpose in daily life. And our target audience is elderly users aged 60 and above, and it can be used in home care assistance, community or senior care centers, and usage in personal daily routine management. And we have 3 layers in total. First is UI layer, responsible for display and interaction. Logical layer have
manage task flow, reminders, games, and reward system, and data layer to store users' profile and daily records. For model vs our self-developed, current model exists including UI framework, storage mechanism, standard AI chat model, and basic monitoring, while we develop task and reminder logic, reward system, system flow control, and gamification, also mini game integration and emotional feedback. So our major contribution include companion system to provide emotional support, shifting monitoring to companionship, and encourage proactive behavior. And second is gamification. We have 3 games in total: puzzle, nostalgic music, and Q&A, turning tedious tasks into interesting activities. And last is integrated system, using combined UI, reminding, tasks, games, and emotional feedback in one human-centered system. And for teamwork, I'm responsible for the PPT and presentation, and my group mates responsible for poster and coding.
Okay, so first, user can input their So first, user can input their name. So here's a daily schedule card. Integrate keys information from other pages, such as medication reminder and working missions. Okay, so this is the daily medication list. Display schedule, medication times, and names. After taking the medicine, seniors can tap a button to mark it as done. And he also provide manage system. Then add the medicine you need to eat and the time. And below is the reminder of what drinking water. And the measuring of blood pressure. And this is the workout measure.
This is a safety checklist. Provide a checklist before going out, including items like wear mask, bring water bottle, or else. So before going out, the elder can tap this button, and after the exercise, he can tap the finish, and will get the park memory photo. So here is the park memory photo, and users can also check the past live record and download the backup data.
Here we have we can use this to press and recording. 小时候妈妈对我最严格，小时候妈妈对我最严格。
简单讲一下这个。
We can use this to record the words that you say and put it into the AI chatbot powered by Gemini API. And for example, we use this and he will give out feedback. This is for debugging. Also, we can use typing.
Hello everyone, we are good voice AI trainer. I'm Junior, 他是庄总。Well, research motivation is the world is becoming aging society. Managing health for elderly is very important issue. However, the elderly-based digital barrier is hard for elderly because their poor vision. And smart devices are too difficult to use, and also they also forget something like telemedicine or access. And for core concept is a voice operator design assistant where user can just talk to the computer. It has three main goals: natural input, by just simply speaking and helping information. Assign elder to experience a good life happy by the mind. Three is self-management. You can trade it, help elderly to trade it help. And this is our system by step. And first, the user speak the comment, and we use Google API to turn speech in text. and you will analyze it is keyword, and then you will store it in a TXT file. And in the end, you will visualize it by soundtrack. The main program logic flow. The system will operate an infinite loop, constantly waiting for user the input. We have a function. And it is A1. Function 1 is a record, it's generating both the weight. And function 2 is a record weight. It's just a number by your weight. 3 and 4 is the chart bar. And 3 is the weight chart, 4 is the bar chart. 5 is reminder. You will remind them you forget something or not else. 6 is the daily summary. You will tell you today's what you do. And 7 is the day search. Just search your hash level. 8 is the cost of program. And we use a speech recognition library to create and we also set a time limit for the system that doesn't wait too long. You use the Google API for check manually. And for the data, we use the reverse logic. For example, if a user say, 我今天60.5公斤，它会 you will capture the number and save it automatically. You also do the keyword like 要或运动，然后 also you will save it automatically. And the system will reload file line by line, and you will calculate the exercise meaning for the next bar chart. And you also have a schedule just by hour. And you will run a pending loop. 就表示他们要做什么。然后最后你 next summary today just tell them what you do. Just a daily snapshot. And search by day, just search page view. Is our model developing. Yes. And it's reasoning connection and data and test taken. Also a burden model. We just context logic and main calculate. Data visualization. We have two charts. One is the weight chart. 2 is the daily exercise time. Major contribution. 1 is the meeting. In computer or mail system, I both driver to user. And we combine the cloud-based speech test with your local data. And we made the home management easy for everyone. It's our contribution. Now demo time.
So this is our program, and there are 8 functions as remind. So the first one is you can record a new voice statement into our TXT file. 今天早上10点30-20分钟。And yeah, it will show the result on it, and also store the information in the health log.txt. And the second one is same as the first one, but it's only for recording the weight.
我今天体重69公斤。
Yeah, so it capture the keyword 69 kilogram. And the third one is showing the weight chart. And there also show the date and the weight trend chart, yes. And the fourth one is the exercise time. How long have you exercised at that day, on that day? And the fifth one is a reminder. We have set a lot of alarm in the program, and then to remind the user to do anything. Yeah. And the sixth one is a summarize of today, so we can see where to record on the screen. Yeah. And this last one is to search by the date as the input. So we search the date and we will show what it record on that day. Yeah, and that's it. Thank you.
Okay, so hello guys, I am Laisan and this is Wu Mingyong, and we are presenting ElderFit, a personalized fitness app for the elderly powered by AI. And our motivation is sarcopenia, which many elderly are bothered with, and it could lead to several problems like heart attack. And we proposed our solution, which is an AI-driven fitness app called ElderFit. And here's our key features. First one is a health risk assessment. We use an SARCF questionnaire to determine the sarcopenia risk for the user. And we have an AI personal trainer which uses real-time pulse detection using Google ML Kit. And it gives an instant visual feedback on posture. And the third one is progress tracking. We have daily check-ins, strength tracking, and a visual calendar on the homepage. And so for the assessment, we've used a SARCF questionnaire, which is one of the official way to detect sarcopenia, which evaluates strength, assistance in walking, rising from chair, climb stairs, and falls. And it will output a risk score from 0 to 10 to categorize user as low risk or high risk. And our AI training technology is powered by Google ML Kit, which detects skeletal landmarks and calculates joint angles to verify exercise form. And we support a variety of exercises, including bottle lift, overhead extension, ankle weight leg extension, and chair stand. And here is our tech stack. It is an Android app, and for the backend, we use Firebase to store the user data in the questionnaire results, and also for anonymous authentication. And the database is also responsible for generating personalized training plan. And here is our future roadmap. The project can be more complete if it has social sharing, telehealth integration, voice control, and more training exercises. And it's our demo time.
So when elders use these apps, they need to fill out a questionnaire first. So wait a minute.
The emulator is kind of slow, so we are going to play this pre-recorded video. This is the first part of our demonstration. Here's the home page that's on the calendar. It marks green for the users that are using this app. And this is the questionnaire screen. As you can see, the user answers 8 questions. And after finishing, you can see the risk score, and it generated a personalized plan for the user. And the second part of our demonstration is the training screen. So this is also a video. So the first exercise is a bicep curl. Just looks like this. And the second exercise is simply raising the arm. And that's it for our demonstration. And you can download our app by scanning the QR code if you want. And here's our live demo. Okay, so thanks for listening.
Hello everyone, I'm Zhou Kaiming and she is Cai Mengjie. And our topic is Plan-Made, an AR plan diary for elderly companionship. And this is an outline. First, about our project introduction. Why we want to do this project is because we discovered there are some problems that elderly users often meet, like social isolation, emotional loneliness, and could reduce daily motivation. And caring for plants provide emotional comfort, but plants offer no active feedback. So we want to use technology to make plants feel emotionally responsive to elder users. Our project is a mobile AR application that lets users photograph the plant and watch it come alive. Also chat with users and help users to solve relevant plant problems. And we use 4 main technology in our project. That first is image processing, which detects plant species and leaf health using color and shape analysis. Second is the AR, that overlay animated characters on the real plant's view. Third, use change detection to compare past and current photos to show plant growth, and use Gemini API to chat and accompany with the elders. Then we're going to talk about the framework. Our system framework is start with user text photo, then analyze photo about average brightness and green to red ratio, classify plant state, give a visual and emotional feedback, and display in a simulated AR interface. And about the app, we use current models such as the built-in UI and system components in React Native to complete the page layout and interaction using pre-built UI components, and use Streamline API to integrate Google's Gemini language model supplies. And we solved the multi-page switching architecture and add less page switching like home page to chat page is handled through state-based routine instead of React navigation. Other developments, such like the integration of the AI chat workflow, such as input validation and safeguard that will check for empty inputs or the missing API keys, and display of the user message before sending the API request, and the thinking typing indicator shown while waiting for the AI response. And also there is the error handling.
And for the AR, we use Unity as the main development in an environment to integrate animation and image and analysis logic. And also Pixel is provided by the Unity engine, but how the Pixel data is interpreted is self-designed. First, we perform image analysis on daily plant photos. Using pixel-level access, we calculate two main visual features, the average brightness of the image and the green to red color ratio. These features give us a basic understanding of the plant's visual condition. And next, we apply rule-based decision logic. Instead of using complex AI models, we define simple thresholds and interpret the image features to classify the plant state as either normal or thirsty. Finally, the plant state is mapped to emotional feedback. Each state corresponds to a different visual expression, floating in animation, speed, and dialogue text. In this way, raw numeric image data is transformed into emotional and intuitive feedback that every users can easily understand. And next is our major contribution. First, regarding novelty. Our core concept is anthropomorphic interaction. Instead of presenting cold raw data, we transfer image inputs into warm, reliable moods. By combining generative AI with rule-based vision analysis, we have created more than just an app. We've created a plant companion that is both logically grounded and capable of human-like conversation. And second is our social impact application. Our focus is strictly on elderly companionship. And like most commercial apps that prioritize horticulture or how to grow a perfect plant, PlanMate prioritizes the user's well-being. We aim to lower the technology barrier, so we specifically tailored for senior users, featuring enlarged typography in both the app and AR animations to ensure maximum readability and ease of use. And last is our teamwork. Okay, let's go on to the demo. We provide a pre-video.
Okay, and this is our PlanMate app. And click the camera button and go to the AR camera.
The system immediately performs image analysis. It calculates the GR ratio and the brightness values determine the plant's current state, like now. Based on this data, it displays a corresponding character, animation, and feedback text. Crucially, the system records this data to compare with the next photo. As the data change over time, different animations will be triggered to reflect the friends' news status.
Okay, then go back to our homepage and go to the diary. And here is the place that we saw the data of the candidates after the AR analysis. And the user can leave and send message in the diary about their plans. And also people can update their diary. Then click the third button is the chat room. People can ask relevant plans question and get answer here.
Casual conversations or ask specific questions related to plant care. Okay, so that's all for our presentation. Thank you.
Hello everyone. Our project is a smart assisted game app designed for dementia patients. So this is our team members. Good. this is our comment. So, cover our motivation, app design, and model training. So as we know, Taiwan is becoming an aged society. By 2024, the number of people with dementia is expected to exceed 350,000. So taking care of these patients is a huge challenge. We need two main things: a regular daily routine to maintain a normal life, and a necessary social interaction to keep them emotionally supported. So our goal is to design against all this need. So this app includes daily schedule game. As you can see on the screen, the app lists daily tasks like eating medicine or taking a snack. So when a patient completes a task, for example, taking a photo to prove them brush their teeth, they can check in to earn the points. We could stop. So let's talk about UI design. Okay, sorry. So let's talk about our UI design. And our UI design use high contrast color and a simple layout to avoid confusion. We also use large text and button, and the layout automatically adjusts to different screen size. And this is our model training. So first talk about model training and speech to text. So our speech to text have data processing and model training and transports the text to the voice. And first, we collect voice data and remove background noise. Then we extract features using FFCC. Finally, we will use deep learning model like Transformer or RNN to convert sound into text. And next is use AI API. We will use AI API and use prompt engineer to give the AI concept. So it knows exactly how to assist the user. So one is AI as an interactive feature, and second is AI as a functional tools. So this is our resource, and we use Gemini to support our work. And we are no demo, so this is our work contribution. We are no demo, so thank you. Okay.
感谢放写分目表。
是名字自圈。
因为我们是做海报组。
哦，所以没有收东西。
对。
然后也要有给。
真的没有收东西，都没有。
没有。
就是海报。
好看都没有，是不是？
就是我是张经纬。
我是黄建伟。
还有李小友。
你们知道老师有说你要怎么做吗？哦 ，OK， 好。
Hello everyone, now is our presentation about our final project, Memory Companion AI Assistant, and my name is Perfect. She is Hariting and she is Shichao. And here is the table of contents. And first is the introduction. Why we want to do this final project? Because we want to solve this three problems. The silence, academic gap in care, and mental health. So we decided to provide a consistent, personalized emotional support via an AI companion. And our key advantage is we have a persistent memory system that can remember users' details like name, habit, and routine. Okay, now I will introduce our project framework. We use Godot for the front end, and we use Python for the back end. And most of our projects I use an API, and we use the open router because there are a lot of free LLM and API out there. And the most important thing in our project is this dual memory system. We have season memories and summary memory, and we use this fast index to find the most relative memory to let our projects to have a memory system. Yeah. And in our projects, we have different personality. You can switch the personality you want for this data. Okay. And the things we self-develop is these 6 things: dual memory system, constant logic, and a personality manager, robust Godot Python IPC bridge, and smart calendar agent logic. And we will introduce this after that. And because for the elderly, so we have this soap opera generator and the speech-to-text pipeline integration. And now I will introduce the current model we use. And because and so we have to change the sentence into an embedding. And then we have to use a library to find which is the most relative comments in this. So we use this This is a library that developed by Meta. And now I will introduce the model we use. The main conversation language model we use is this. It's one of the model on the open browser and it's free.
For the Meta gamma frequency model, we use it for two functional tests. First, for the story generator, it creates creative song opera scripts. And for the calendar agent, it analyzes the user's input to understand the schedule. And for speech-to-text, we use Grok to run the whisper model, allowing real-time voice input for chatting. And for text-to-speech, we use Google to convert the generated story into audio. And finally, for the calendar, we use the Google Calendar API to actually make changes to the event.
And next is our major contribution. We have dual memory system because we have short-term and long-term memory, so we can remember the detail that elderly can feel cared for. And next one is interactive storytelling that can make the elderly who are interested in soap opera that they can make the story by themselves. And the third one is smart calendar agent that can capture an important event in conversation and that can remind the elderly. And the fourth one is tailored emotional companionship. The user can customize AI systems, avatar, and personality. And the last one is SST technology that can make some elderly who are not good at typing, they can use speaking to chat. And here is the teamwork. And next is demo. First is the personality management. You can choose the personality you want, and then you can chat with it. You can speak like.
你有推荐的食物吗?
And send it. And because it needs to wait for a while, so I can introduce other functions. Like this memory statistic, it can show the long-term and short-term memories number, and it can clear the short-term memory and save the memory immediately. This one is memory statistic. And next one is soap opera. Here is you can choose which type of story you want, and if you don't know which type of story you want, you can generate by it. And here is the recommend, like this. And also you can use like and in the soap opera, like if you want to watch 霸道总裁爱上我, and you can switch, print it in the plot and like choose the style, and it can generate the story. And here, this AI capture the event, so AI will ask you, do you want to join to the calendar? And I say yes. Yes, and after finish, if you want to listen this story, you can play it.
我记得那天像昨天一样清楚。
And you can stop it, and you can save the story as a TXT if you want. And if you want to see the second second story, you can have this one, and it will generate a second one. And maybe you can show this one. Calendar, if you say yes, and it will join to the Google Calendar, like this one. Yes. And after finish it, you can click and leave, and it will save your long-term memory to the system. Yes. Thank you.
应该是最后一组喽，大家记得填那个笔试。
Good afternoon, everyone. I'm Zhen Junliang. I'm Zhen Junliang. He is Chen Taixiang, and she is Liu Jingyuan. And today we would like to introduce our project, Trip Down Memory Lane. We focus on two main problems, the first being loneliness and disconnection from family. Even when elders are surrounded by meaningful objects, such as photographs, they often lack opportunities for interaction and shared storytelling. The second problem is memory decline, including dementia. Many existing cognitive training tools are either too complicated, impersonal, or unengaging for elderly users. This is why we wanted to design a solution that is simple yet helpful. Our solution is a photo-based memory preservation and interaction system. Users upload personal photos, and the system analyzes them and creates a prompt as well as a quiz. We hope that the quiz could help the elderly by being a daily task to keep their brains running. The system includes several key features. Key features such as the users can upload photos and edit the AI-generated memory stories to make them more personal. The system also generates interactive quizzes to gently stimulate thinking and recall. For accessibility, we provide both voice recording and text-to-speech features, allowing elders to listen instead of read if needed. From a design perspective, we also emphasize elder-friendly UI elements such as large font sizes, simple buttons, and clear interactive cards. We hope that this system and quiz can be used in multiple settings, such as family bonding, elder care facilities, and even cognitive training programs as a daily activity. What makes our project meaningful is not just their technology itself, but how it is used to preserve memories, support cognitive health, and strengthen human connections. Our system integrates multiple AI services. We use Google Vision API for image analysis, the Hugging Face Inference API for text generation, and Google Cloud Text-to-Speech for audio input. The front end is built using React and TypeScript to support a clean and responsive interface, while the backend uses Node.js and Express to manage and connect all AI services. To protect user privacy and improve performance, all memory data is handled locally using IndexedDB, so that personal information is not stored on external servers. This is how our core flow works. As you can see, we have split the front end and back end so that everyone can see how our system works. What makes our project novel is that it combines AI generation, image-oriented memory interaction, and a design specifically tailored for elders. More importantly, it helps elders preserve their memories and stay connected to their families. As you can see, for the contributions, we try our best to split the work equally, with two people working on the front end part and another one working at the back end. Let's move on to the demo. We will first show you a video of our demo. So we can turn dark mode and light mode. And we will then upload 3 pictures. So here we can add additional information so that the prompt comes up better. And after that, it will be saved to the memory. And we can generate the prompt from here. So here we can check the stories, and at the back end we can see what the API gets from the image. Yeah, so if you weren't satisfied with the prompt, you can actually edit the story itself, and you can generate the quiz from here. So you are given the option to record either your own voices or leave it as is for text-to-speech. And the quiz will be
第一题，阿华在法国旅行时和谁一起欢乐地记录下回忆 ？A. 女朋友 B. 朋友 C.
Yeah, so that will be the text-to-speech. And after answering all the questions, there will be a result page. So here we can actually access the quizzes even in the future. And that will be all for our presentation.
该没有人没报告到啊。OK， 大家可以下课。那个认知障碍游戏来找我一下好不好？做认知障碍游戏。
记住下礼拜期末考，要记得来考试，因为连续2周都放假嘛，2个国定假日，所以下礼拜才会下礼拜才期末考，下礼拜嘛，期末考对，因为下。不是，因为我们连续2周放掉。
对，
我们不是25号放假嘛，1月1号又放假嘛，所以就连放2周，不然应该下礼拜就考试了。对，那
前3名。
你说什么？
前3名会多
如果你真的觉得你做得很好，其实也做得还不错的话，那 OK 啊 ，OK 的。
要